This question is all about transformations of graphs to begin with, a couple of marks on that, but then after that, solving equations using your trig identities and your other tricks and ways of solving equations. So we're going to dive straight in. Here they've given us a graph, and the equation of the graph is 5 cos brackets x minus 30. So as soon as I see that and the graph, I'm thinking, well, how does that relate to the normal cosine graph? So let's have a quick look at the normal cosine graph. Here we go. So something like that. Okay, going up to 1 and down to -1. And the graph we've been given has actually got two things, sort of transformations attached to it. So it's been moved to the right by 30 and it's been stretched in the y direction by a scale factor of 5. So this graph they've given us actually has been moved to the right by 30 and also stretched upwards by a scale factor of 5. So if I just sort of kind of aim to roughly show you what that looks like. Something along those lines. So essentially we've got the original graph y equals cos x, and we've got the graph we've been given y equals 5 cos x minus 30. And what we've got to do is try to figure out where this point here, P, is. Well, the corresponding point on the original graph is here, 180 minus 1. But remember what we said. We said that this graph, the dotted one, the one we've been given, has been moved to the right by 30 and stretched by a scale factor of 5. So the same is true of this point here. This point will have been moved 30 to the right and will have been stretched 5 times downwards. So I think 210 for the x-coordinate, remember that is 30 to the right, and then 5 times further down, so -1 times 5, -5. The answer for part A is 210 minus 5. For part B, we have to look at solving an equation. So moving away from the graph now, I suppose. We've got 5 cos, sorry, I can't write properly. 5 cos x minus 30 equals 4 sine x. That's the equation we've got to solve, and we've got to do it for all values of x from 0 to 360. So how are we going to go about solving an equation like this? Well, as soon as I see something like this, cos brackets x minus 30, I could use not a double angle formula, but an addition formula for that one. So I can expand that using the addition formula, and the addition formula for cosine is cos A cos B, and this is really the subtraction formula, plus sine A sine B. So you can see here how I have expanded that bracket, if you like, cos x minus 30, and I've used I call it the addition formula, but the other version of it, the subtraction formula for cosine, and you get cos A cos B plus sine A sine B. How am I going to sort of deal with this? Well, actually, the good news is that a number of these things are things that we already know. So cos 30, you know, is, oh, hang on, is that root 3 over 2? I think it is, isn't it? 5 times root 3 over 2 cos x plus, and remember sine 30 is 1/2, so 5 times 1/2 times sine x, like that. Simplify these as much as you can. So yeah, 5 root 3 over 2 cos x plus 5 over 2 sine x equals 4 sine x. Take away the 5 sine x from both sides. So not 5 over 2 sine x. So here we've got 4 sine x, taking away 2.5, which is 1.5 over 2 sine x. Okay, so I've taken away that 5 over 2 sine x from both sides of my equation to give me to this result. And then I think I'm going to divide both sides by cos x. Remember that sine divided by cos is tan x. And from here, you can probably see how we're going to go with this. I'm just going to go onto a new page quickly. So 5 root 3 over 2 equals 3 over 2 tan x. Let's double both sides. Divide by 3. And then it's the inverse tan. In that case, that gives us 70.9. Don't forget though, they want all of the solutions in the range 0 to 360. So because we were solving a problem with tan, think about where your second solution for that is going to be. If your first solution is at 70.9, your second solution for tan is going to be at 70.9 plus 180, because the tan graph repeats every 180. That gives you 250.9 degrees. And those are both of the solutions to that equation. Okay, let's have a look at part C. It says, deduce, giving reasons for your answer, the number of roots in the equation 5 cos 2x minus 30 equals 4 sine 2x. So the first thing to note, and also between 0 and 3,600, not 360. So how do we sort that out? Well, let's compare the two equations. The equation we solved in part B was this. And remember, that had two solutions. The equation we're being asked to work, sort of not solve, but tell how many solutions there are, in part C, looks like this. So what's changed? Well, what's changed is that in this equation, we had just single x's, and in this equation, we've got two x's. That is like a stretch in the x direction. Think about the two graphs there that you might draw, right? This graph and this graph. If you drew these two graphs, and then you drew these two graphs, you'd find that these ones were stretched in the x direction, scale factor a half. So scale factor 1/2. Now, what does that mean? It means that they're going to cross over twice as many times. All right, so if you had these two graphs, they would cross over twice. But if you had these two graphs, because they have been stretched by a scale factor of a half, there will be twice as many solutions in the range 0 to 360. But don't forget that we're asked to do it in the range 0 to 3,600. So if there are 4 solutions in the range 0 to 360, in the range 0 to 3,600, there are going to be 10 times as many solutions, which is 40. So we need to sort of explain that rather than just sort of stating 40, need to explain it. So write something. I'm not going to write a full sentence here because you see me talk through my workings, but write something along the lines of, there were 2 solutions there. We've done a stretch scale factor of a half, giving us twice as many solutions. And then the domain, I suppose, is that the right word, is 10 times bigger. So we're doing 10 times 4. And that is it.